Greetings and welcome to my new calculus channel. My name is John Gabriel, and in today's video I'm going to discuss a special topic that I introduced several videos ago. Now in this video I'll talk about the fact that the derivative function of any particular function has the same range, okay, and that range, well, has the same range, or actually falls into the range that I'm going to tell you about right now. So this is the range. It's from minus pi over 2 to pi over 2. Okay, so every function will fall, the derivative of any function, it doesn't matter which one it is, will always fall in this region. Okay, so, and you're about to see, and what I mean by that, I don't mean the standard derivative in terms of rise over run. I mean the derivative in terms of angles. So for example, Newton used rise over run, but the ancient Greeks used angles, and this means that every point in a function, if it's defined, has a derivative, and it's defined in terms of angles rather than rise over run. And the only time that rise over run isn't defined is when the tangent line, supposedly the tangent line, is vertical. Okay, and of course mainstream academics don't understand tangent lines. They have incorrect definition, because a tangent line by definition may never cross a curve. That is one of its special attributes. That's what makes it a tangent line, the fact that it may not cross at the point of tangency. It may cross at other points, but not at the point of tangency. So let's see now what this derivative function actually looks like in terms of angles. So if we plot the function in terms of angles, this is what it looks like. And as you can see, its range is between 0 and pi over 2, okay? And this is very interesting because nothing about this has ever been published, and most mainstream academics are totally oblivious to this because they've never understood calculus, and they have no clue why calculus works. In fact, they don't even understand the fundamental theorem of calculus, and they have further divided it up into two parts when there is really just one part that is derived directly from the mean value theorem. So what does a derivative angle function look like? Well, it's this function here, right? So if we put the trace off, this gray function is the function expressed in terms of angles. And of course the actual derivative function as rise over run would look similar to this, but would have an asymptote here at the value of 1, of x equals to 1. So as you can see, this this understanding is quite deep, and most mainstream academics won't be talking about this, but they'll go on about what the derivative is, and really all the derivative is another function. It's just another function. It's just another simple function. Now you can take any particular function that you like, and this will also have a, let's just get rid of the trace here, and I'm wondering why it's not getting rid of this. Oh, that's because I've got this on. Okay, so now if we do a trace here, this is what it looks like. See, so this is the derivative, and it's always going to fall between pi over 2 and minus pi over 2. So this is something that I revealed to the world. There's much more that I haven't shown you about this, and a lot more interesting facts and properties and theorems, in fact, of this particular approach, which mainstream academics are totally oblivious to. And if we have to look at this function, once again, okay, so it's showing us the derivative for the previous function because it's hard-coded. But if we did, let's see if we can change that. So that would be 2t. So we would have to say inside here, this would have to be 2t. Let's just delete everything. See if I can do that. And delete that and say 2t. And so there you go. So we take the trace off. You can see the derivative angle function. Now, listen to me, people. I am a genius. I am very, very intelligent, and I know what I'm talking about. Your math professors are idiots compared to my intelligence, and no one in the history of humans understands calculus as well as I do. Not a single other human being has ever come close to my understanding. So I'm going to put a few links in the details section, and I encourage you to read them. And I'll also put a link to this applet so that you can choose your own functions and you can verify that what I'm telling you is true, that the derivative angle function will always fall between these regions. And basically, I'm telling you that the derivative is just the derivative function is just another function. That's all it is. Okay. My name is John Gabriel. This is a new calculus channel. Till next time, goodbye.